You're going to get a small glimpse of what infrastructure is being built up here every year. So please give it up for all of the people of our various infrastructure crews. And we'll start with Leon and the 32C3 NOC review.
All right, good morning, everyone. This is the NOC talk. So I'll start with the bad news. We had no sauna this year. The issues were quite interesting this year because we had some problems acquiring backbone hardware, which was quite serious. Usually, we had a sponsor who lent us a ton of equipment that we could use, and that we had everything from one source, and that was really easy. We just sent a wish list, and we got everything we wanted, and we could build the nice network with many features that we didn't really need, but just made it fun to have. This year, however, the sponsor had already agreed to do the same thing again, but then they had some internal difficulties, so they couldn't do that, and we learned that basically 1 week prior to build up. So I got a phone call, and we basically were left without any backbone equipment. So it was back to the roots. What have we done the years before? We called many people, and we got many offers from amazing folks who helped us out. We decided that basically everyone in the NOC would bring his Fritzbox, and it would be fine. So the temperatures were fine in all rooms. The Fritzboxes don't have that much energy to dissipate. So this happened. Now, what we seriously did was some emergency planning. We got help from many amazing companies, especially we have to thank Teamix, who are in Nuremberg, a company. They've been incredibly helpful arranging stuff from their storage, talking to people if we can use their stuff. And we spent many hours on the phone late in the evening with a man from Teamix, so that was really helpful. Thanks for that. Other companies helped as well, especially Huawei via the company called 10ICT, who lent us some routers. SecureLink, which is another Netherlands company, helped us with equipment, and eKix lent some. They've lent a big router and switch, which we used in the data center. So what we ended up with in the end was this equipment. It's basically. Basically, it's a mixture of many vendors, which made the network very interesting to build. But it worked out pretty nicely in the end. We even got the Force 10 router, the E600, which we had first used at 23C3, which we got from a friend of mine, well, a friend of us. The good thing about that is we don't have to give it back. So that was really useful. Yeah, you want to continue in the backbone?
Yeah, sure. Hello? Is this thing on? Okay. I think that's working now. Thank you. Yeah, with all the equipment we got in, we went in and did basically within 1 week a complete redesign of the backbone we had. We knew, of course, in which patch rooms we needed to go and how many ports we need in each patch room, but the whole VPLS routed setup we had before was, oh yeah, this is, maybe you can see it in the first 2 rows, or if you have really sharp eyes out in the back rows, but yeah, it's also later in the slides. So yeah, we went in and redesigned the whole backbone basically. This year we just did a simple layer 2 backbone, no VPLS, nothing fancy. We just needed to get it running. The routing was done mostly usually on the Huawei's in the larger patch rooms. And we were, since we've been here in the CCH, actually, we've been in the data center of IPHH, where we were connected to upstream ISPs and had 4 times 10 gig WDM backlink to the CCH here. And then we had a couple of upstream ISPs too. For the first time, we had 10 gig from Deutsche Telekom here in CCH. So for the first time since we've been here, we had actually redundancy on the uplink. If the uplink to the IPHH would fail, we would have still 10 gig to Deutsche Telekom for internet traffic here in the CCH, which was pretty cool to have. And then at IPHH, we were connecting to eKIX, Internet Exchange Point, to Kaya Global, KPN, and LWLcom, our 3 other upstreams. And at eKIX, we were mostly doing peering with the route server. Later on, there came peering sessions to Kabel Deutschland. And we had 2 peering requests from one ISP, which didn't set up the BGP session, actually. So we're still waiting for it. They have still a couple of hours before we shut down our equipment, so maybe we'll get it in the end. Yeah, and with all the actually quite big ISPs we had as an upstream, we had some problems, or no, some challenges, difficulties, balancing between those uplinks. We were moving around traffic a bit from some ASs from one uplink to the other and stuff like that to balance it out and to find good connectivity basically for all of you. And in the end, I think we managed to do this, and we had quite a few complaints. And the DDoSs were coming in pretty fast too, so I guess we were pretty successful with that.
So after all those years, we used the E600. Basically, many years in Berlin. Then we didn't use it in the CCH, and we used it at camp again this year. We finally found its limits. Because this was always like that one box that always stood up to the challenges of the Congress. But this year, I think we filled its TCAM table, which couldn't hold more than 16,000 IPv6 neighbor entries. Well, it's basically, you have 3 entries per device, so there's not this many entries, basically. So that device was just too small to hold all the V6 traffic. But yeah, we could mitigate that by moving V6 routing to another device we still had lying around, so that worked. Another issue was that for the first time, we actually had a DDoS. So someone tried to attack our network from the outside. Basically, they filled 2 of our 10 gig uplinks with DNS amplification traffic. So that was one evening of some issues for us. It was going against one of the Colo servers, so we don't really know if they were trying to attack the event or some specific server they didn't like. But we could mitigate that with the help of our upstream NOCs, so that worked. What we tried to do with KPN this time, which is one of our uplinks, is to run a 100 gigabit connection to them. They arranged hardware especially to do that test with us, and we arranged hardware to do that, but in the end it didn't work well. We suspected a broken optic, so Flex Optics sent us another one, which didn't work either, so we are suspecting currently a broken line card in their router or something. But yeah, in the end we were stuck with your grandmother's 10 gigabit Ethernet again. But that's fine, we don't need all the bandwidth. It just would have been nice to test the technology. Marcus?
Yeah. And then we had some problems with IPv6 routing on the Huawei's. Basically, they were working quite fine in most locations, but in one of the patch rooms where we had a lot of VLANs terminated, it seems like they were running out of CAM, basically, which is the memory where the addresses are stored in. And we noticed that it was mostly for IPv6 only. We had strange packet loss on some VLANs, not on others. So it was quite a hard problem to debug and to find out eventually. And when we figure out that it has to be CAM related, we were moving most of the routing of the one patch room back to the E600, which made sure that it was still below 16,000 neighbors, of course. And then suddenly the latency went back to normal on the IPv6 networks and everything was working quite fine. We didn't really find out what happened there, but it had to be something like that. And we had the same problem basically with the Wi-Fi network where we had almost like, well, we have the numbers later, 8,000 something users in there. So we were routing that at the beginning on the E600, basically, right? Yeah, on the E600, and there we were running NDCam issues too. Then we were moving this actually to an MX80, so moving around a little bit of locally routed traffic, but then it was fine. And then in between there were some people trying to be funny and sending some stuff to our monitoring servers, which took down some of the monitoring for some time, but eventually we found out that too, and were blocking the IP addresses, and then we could see that all the network was working anyways, so that was fine too. Yeah, and then we have some random nodes, so to speak. We were noticing that the Facebook traffic was really, really low. It didn't get into the top 200 of the AS stats.
Yeah, we were joking that the most Facebook traffic we've seen was that one visitor walking around in a Facebook shirt.
And actually, on a quite interesting note, there was more V6 traffic from Facebook than V4 traffic, so that's good too, somehow. For the colo, we saw this year some requirements. Oh yeah, we need this like 10 times 10 gig. No, it wasn't 10 times, but some people wanted to actually have multiple 10 gig channels for their servers. I mean, we are quite happy to provide connectivity in colo. We were quite happy to provide the colo and do anything we can to provide bandwidth there. But there are some limits. So we think, at least for this Congress, 10 gig was quite enough for one server in the colo. So, especially, I mean, the people couldn't know that we had this problem with the backbone and everything else. But still, I mean, please keep your requirements aligned with reality. That's all what we're saying.
We learned some interesting new facts that, well, people couldn't tell us when we asked. We have OM2 multimode fiber in this building, and with the hectic arrangement of hardware before the build-up, we had a situation where we had to run 40 gigabit Ethernet links between some sites. Well, we would have only needed 10, but we had the equipment only for 40 gigabits. So we had to figure out whether those links would work over this fiber that's not designed for this kind of use. The stuff is specified to run for 100 meters over OM3 fiber, which is better fiber than we have. And we were able to get it working for 190 meters on the bad fiber we had. So that was nice to learn. Yeah, another interesting fact that's barely visible in the slides due to a formatting fuck-up. The maximum outgoing traffic was 21.4 gigabits per second. People always ask for that number, which is about 4 gigabits more than last year. So it's steadily increasing. Here's a pretty graph. It just shows the load on our backbone links. We just noticed that an hour ago. It would be fun to show. This is where we announced the end of the colo, or the shutdown of the colo. So basically, all of you walked to the colo and probably got their servers out. So most of our traffic is gone now. Wi-Fi?
Wi-Fi. We have Wi-Fi. No, but really, we have Wi-Fi. What we were using this time, the same as last year, were Aruba controllers in a high availability setup with 10 gig links towards the core. We had deployed 145 access points throughout the building. In all over the building, we saw 20,000 unique clients. and had a peak of 8,150 clients.
So it's not over 9,000.
Yeah. Our Wi-Fi team didn't deliver on that, apparently. Yeah. So.
Sorry.
On a really serious note, we saw 40% of clients on the unencrypted network, which we really couldn't explain because we were actually trying to push the people on the encrypted Wi-Fi. We had the 32C3 SSID and the 32C3 open SSID. And somehow 40% were ending up on the unencrypted open network. Although we provided an Android app to configure the encrypted network, we had profiles for Apple and Windows, and basically we did everything we could just to get the people using the encrypted Wi-Fi, and still 40% decided, oh no, YOLO. But, well, maybe next year we see a decrease in this number. It would be quite fun, actually.
The obligatory username statistics, because as you know, you can choose any name you want. Number 7 is an improvement from last year. It was on number 11. Device statistics, this time Linux has won. Together with everyone. And traffic statistics, we saw an average of 3 gigabit per second coming from the Wi-Fi, which is, well, it's a sum of received and transmitted data. Peak of 4.5 gigabits. SAL 1 and 2 were the most busy areas of obviously. They had the peak of 1.75 gigabits per second. So in this deployment, we see a much higher average bandwidth usage per user than in normal rollouts of this size. So it means you guys are much more active on the internet for some reason.
Yeah, and we can see this in this pretty graph too. That's the airtime usage on 5 gigahertz in SAL 1. So basically, everything is in use. We don't have any spare frequency anymore. And yeah, we're actually trying to push as much traffic as is physically possible through those wavelengths, through those frequencies that we have.
So this year, our wireless people decided to try to build a probe system so they can actually monitor the quality of the Wi-Fi they've built. Well, before we could just monitor them by, do we have complaints from the users? But this time we have actual measurements, so data. They've built 5 OpenWRT devices with WPA supplicant installed. And then they've run automated tests on them for ICMP ping checks. Can we get a DHCP lease? Let's try to download this file via HTTP and see how long it takes, things like that. So what you can see is, well, the download speed was limited to 15 megabit per second. And during nighttime, when the rooms were empty, you could actually get the speed. But once people would come in, the speed would drop. So that's interesting data to have while designing the network for the next event or something.
We had a bit of problems in the Wi-Fi 2, of course, or challenges. We had some performance issues with the E600 on the first day, which was adding, because it was running out of CAM apparently, a lot of latency to the wireless network and basically to most of the to the network traffic that's going through it. When we moved the traffic away from the E600, the throughput doubled basically after day 1. So we figured out that we reached the limits of the E600, what we were telling you before already. And we were hitting the physical limits in the SAL 1, 2, and 3 most of the time with the channel utilization you just saw. So we either need more spectrum or a more efficient usage of the spectrum that we already have. And in this regard, our Wi-Fi team is asking if there are some people who have knowledge of this area of running a Wi-Fi network for how many have you? 12,000, 15,000 people. And with the bandwidth we're having, they'd like to talk to you about how this can be done. If you have any ideas or whatever, you can get in contact to us. I mean, this doesn't, of course, you can still talk to us, but we don't really need an experience for someone who has like a Fritzbox at home. We still have this experience ourselves, so of course. So that we really need like the experience of engineers and people who are running this high-capacity networks with lots and lots of users and bandwidth. And the last problem we had was the fast radar detection. We had this last year already. We were presenting it, talking a little bit about it. Basically, when there's some noise going in on one frequency, the Wi-Fi just shuts down because it's thinking, oh, there's like radar from the airport, traffic control or whatever coming in, and then it needs to shut down. This is a known bug in the Arubas or something like that, I guess. And it's still not fixed. We're still seeing these problems, but apparently it gets better in the newer devices, which we didn't have that much from, right? 50%. Okay, so 50% of the people will be able to continue using the Wi-Fi when those events come in, which is not too bad.
Another topic is the people who we need to thank. We couldn't get a better picture, sorry. So we would really like to thank the kind folks from the NOC help desk who always are our firewall. They just take all your requests and complaints and they try to help you guys, and they forward the serious stuff to us so that, well, we have actually time to work on the network. So thanks for that. And on a last note, the traditional thanking to the sponsors, because these are the companies who actually make this event possible. It's especially in a situation like this year when we were left without equipment, basically. It was good to have so many companies that you can still rely on who would jump in or who would still provide their other stuff of their respective areas. So thanks for that again. All right, I think we're done. Are there any questions?
Hey, so thanks very much for the great work. Just two quick questions on the Wi-Fi in Halle, in Saal 1. How many access points did you have in Halle 1 in total? And I was just wondering, per access point, were you using only a single channel per access point, or can the access points have several channels at the same time on? Thanks.
Ariane, want to go on that? Here's our Wi-Fi man.
So we were using 18 access points in Saal 1, and those were using pretty much all of the 20 megahertz wide 5 gigahertz channels.
So each one was using pretty much all of them, or did you distribute them, the channels?
Oh, so they were on different channels, yes. So each access point has one 5 gigahertz radio, so and it will use up one 20 megahertz channel.
I guess it's also the controller solution, right? They see each other and they distribute the or did we assign it statically? Statically, okay, yeah.
I'm being told there's another question from the Signal Angel. Is that correct?
Yeah, the most interesting question is, how did you get peering with Deutsche Telekom?
It was actually transit, not just peering. Yeah, well, we asked some folks.
Okay, so it's not reproducible.
Well, we hope to reproduce it next year, but we'll see.
Yeah. Yeah, you can. I can't. I have another one, which is why is the wiki down?
I'd like to stress this year again. We do not run events.ccd.
And I guess the last question from the internet is what funny thing did some users do against the monitoring system?
Some blah, I don't remember. There was some weird packets that put heavy load in the machine or something. Synflood, apparently. Okay, Synflood, easy.
Yeah.
Hi. A few years ago, Nadia Henninger and I did a study where we found thousands and thousands of devices all over the internet that had weak RSA encryption keys for like SSH and TLS because of bad random number generators, and we could compromise all of them for that reason. And I'm wondering whether you guys can help us with this, because a very large fraction of them were Fritz boxes.
We're returning all our Fritz boxes, so we don't have to do anything with Fritz boxes anymore.
Do you think next year you could discourage use of the unencrypted Wi-Fi more by giving the SSID a less innocuous name, like open, instead, and call it like unencrypted or
Insecure or something?
Unsafe or something
yeah, we
like
can
that?
try that. We do have some success discouraging people from using the 2.4 gigahertz networks by giving it the legacy or even slow name or something. So that works. Yeah, we can probably do better than that. Yeah.
Okay, one more.
Wireless question, specifically Hall 1. To get the network working, do you run the access points at full power, or do you have to reduce it to make the cells smaller?
Yeah, we have to reduce the transmit power, so we get cells that overlap the least as possible.
Thank you.
I was wondering, next year, would it be possible to get better Wi-Fi coverage in the bathrooms?
You know, the funny thing is, this was on our list for this year. So I'm not quite sure what failed there. But, well, we're aware. And we're sorry, yeah.
Do you try to turn off the unencrypted network?
Well, we didn't try that. We know what would happen, but we don't really want to. But we would like to discourage users, but we still want to provide connectivity for people who... I don't know, it's a hacker event, right? So if you want, you should be able to, well, have your data sniffed or whatever.
Okay, one more question from the Signal angle.
Yeah, how many abuse messages did you get?
I'm sorry, I don't have this number this time around.
Kai is coming.
Oh, our abuse handling person is coming.
So it is. Hello?
Hello?
Scroll.
248 mails where like 95% are automated about port scans, because it's still just used for stupid port scans, the network, most of the time. And we had, I think, roughly 10 calls where one was more or less serious and the other ones were like really unimportant and easily to fix.
I've got one of those calls. Someone has sent a spam email. Which is, of course, not a good thing to do, but yeah.
Okay. Thank you very much.
I think we're done.
Okay, all right. Who's next? Blank stares. Yeah, that looks like a VOC review. So, if have any people left the room? Do we have new free seats? I see 2 over here, 1 over here, because we have people standing in the back, so they can find a seat. All right. Yeah, just keep coming, keep finding the free seats. People keep their hands up. All right, then please give it up for the VOC review.
All right. Hi. Is this on? Is it? Oh yeah, now it is. Okay, so as some of you might know, last year we were more or less a virus operation center with half our team falling victim to the Kongressseuche. We tried to do better this year, and well, it more or less worked. We have a few sore throats, but no casualties this year, so I think we did all right. So the setup was more or less similar to last year. We had in each of the halls, we had 2 to 3 cameras, 3 in the first 2 halls and 2 in hall 6 and hall G, being mixed with hardware video mixers and lots of equipment in between, which mostly was made by Blackmagic Design. So video mixers, signal conversion, converting HDMI to SDI and scaling and stuff, and backup recording to SSDs and so on. We got requests to talk more about how the actual signal flow looked like, so I included one of the pictures from Hall 2. So I'll use the cursor probably. So this is where the speakers insert, the speaker signal gets inserted, which goes to a switcher, which also outputs to the projector and can also loop back to the video mixer, which is connected to cameras. I can't read that. Oh yeah, and there's a scaler for feeding back the output from the screen to the video mixer as well, so we can take the info beamer, which is the thing which plays during the breaks, and put it on the stream as well. One thing we do, which might not be obvious if you haven't done video stuff before, is that we embed the audio signal later in the chain. So the video mixing itself happens without the audio, and we have a central, I have a slide, the next slide is about that. We have a central place where all the audio from all the halls gets collected and mixed and redistributed, and we only embed the audio after the mixing, which makes a lot of things easier, but also causes problems from time to time, because you it's not local. So if there's a problem in the hall, you have to call up to the Zentrale Audioregie, we call it, and talk to them, and that caused some problems, but we were able to fix most of them, at least in the releases, if not in the streams. Yeah, so then we split the signal to one backup recording, which is just recording everything on SSDs. We hope we don't have to use that, but it has saved us a couple of times this year already, and we had that the previous years as well. And then they go to 2 separate boxes, one of which does the recording, and the other one does the streams. So yeah, and this is the control panel for the, that's not the control panel for the mixer. So that's Hall 2, which is slightly more complex than Hall G or Hall 6. Hall 1 is mostly similar. Oh, and we also have a GoPro input, which is the one in the front for if somebody has to or wants to show something like hardware or so on. So yeah, I think I covered everything more or less. All right. We also have. That's the only picture I got. We have like I said, a big audio mixer which collects all the audio signals and all the translation signals as well, so we can balance the levels after the audio mixing done by the CCH itself. So we can react more quickly and do some stuff which wouldn't be possible otherwise, like ducking in the translation streams and so on. We also did the Sendezentrum this year. Again, we already had that last year, and we decided to do some experimental stuff or research. We wanted to have a software video mixer which can do HD. For the smaller conferences we do over the course of the year, and one of our team was developing such a video mixer, which is called Voctomix. It is based on GStreamer, and we decided, we have to try it sometime. So, we actually tested it before, of course, but this was really the first big conference where it was in use. And it worked surprisingly well. We had some minor hiccups, but I think there was no lasting damage, as in all the recordings got through. So if you'd like to see how, or if you need HD capable software video mixer, it's open source. You can go there and please send patches and so on. So about the recordings, we had about 133 hours worth of talks in all the halls together. So that doesn't include Sendezentrum, because that was tracked in another project in our internal system. This is only hall 1 to GN6. We do releasing in 8 formats, so we do HD releases, SD releases, each of those in MP4, which is H.264 and AAC, and WebM, which is, in our case, VP8 and Vorbis. We also do audio-only releases, and because, most of you, if you go to Media CCCD and try to watch the talk in your browser, you might notice that you get a random, like either the translation or the original's audio signal. And this actually depends on the browser you're using and the phase of the moon and whatnot. Is actually the only browser which handles multi-language or multiple audio tracks in video files on the web correctly is IA10. So that's pretty sad. So we also demux. We create additional releases which only contain single audio tracks to cater to broken browsers. So if you have issues like that, getting the wrong audio or something, just download the file and try VLC or something. So in the end, this amounted to more than 1,000 hours of encoding and actual files ending up on various servers. If you have in CPU time, that's probably about like 5,000 or 3,000 hours of encoding time. All right, the releasing status. This year we were allowed to record almost all talks, but one, which was the play in Hall 1. When I made the slides, we already had released 130 of those 152 talks. This number is probably higher by now. We'll try to get most of, or as many talks as we can out until we have to leave and until the network gets cut down. So we hope that, most of them will come out today, and the rest will hopefully come out soon once our hardware has traveled to its home again and we've gone to the rest of the releasing process. So the talks which are not going to be released today will hopefully happen in the next 1 or 2 weeks tops. Yeah, so you can go to mediaccc.de, or we also publish the talks on YouTube. All right, streaming, on the other hand, it was pretty similar to last year. We dropped, finally we felt comfortable dropping RTMP. So only HLS and WebM, with the majority of the viewers actually going to WebM because browsers, the only browsers which natively support HLS are Apple devices. So that was about 10 to 20%, I think. And this year we'll also be able to offer HTTPS on all relays, like for the website itself, but also for the stream. People came to us for the past few years and requested that. So we built that this year. And that was mainly possible thanks to Let's Encrypt, because we have lots of servers and like either getting like huge amounts of wildcard certificates or going to the process of getting like 50 different certificates by copy pasting CSRs somewhere. Just isn't fun. So Let's Encrypt made that easy for us. That was quite nice. So this is how CDN looked like. The servers you see in the bottom, that's 17 if I didn't miscount, is the ones which were serving streams to the users. This is our source, which is in a colocation space here in CCH. And we have a distribution layer which just handles the load of actually pushing the data to the edge relays, because one edge relay gets fed with approximately 300 megabits, just all the streams. So we can't do 17 times 300 from just one server. So that's why we have this distribution layer. One of those was two of those servers were in the United States, actually. So people coming from the United States were pushed to a local server. We also had a server inside this building, and also went to pushing people from 3233 to that local server to ensure that you don't have, or you have like less round trip time, more or less. PeakFefe is still a thing. So you can see PeakFefe over there. That was like 5,500 viewers in Hall 1. We also have a little Peak Jeopardy over here. Yeah, so we ended up serving almost 20 gigabits of streams at the peak, and well, less than an average, so something like 10 gigabits, which was 10 gigabits on average during a normal day, which was quite a bit more than last year. So yeah. One of the reasons is that we actually enforced HD by default. Last year we had HD as an upgrade path, so to say, and well, that seemed to have worked. We pushed more than 100 terabytes of stream data to users altogether. And as it turns out, streaming to Deutsche Telekom isn't really fun. We had to actually push Telekom customers to a specific subset of servers which had less than shitty peering to Telekom. So yeah, and actually most of the Telekom traffic was served from CCH itself via the NOC link. So thanks for that. That has helped a lot. So there are a few other teams which are, well, not exactly the video team, but related. So I collected some statistics from them as well. So first there's the subtitling team, which this year again did live subtitling in halls 1 and 2. And they subtitled 82 talks, which was all of them. And the number of characters they typed was 2,014,021. They had about, I didn't get these numbers in time for the slides, so I'll just say them. They had like 60 angels, which did that, so that was great as well. And speaking about angels, we had like video angels manning the cameras and the video mixers and so on. That was about 250, so well done, thank you. I tried to call the translation team, but their phone just didn't answer the phone. So I pulled these statistics out of our recording system. So these are not complete, but they give you a rough idea how the translations were distributed. So we had 3 German talks which weren't translated and 9 English talks. But comparing that with 105 English talks which were translated to German and 19 German talks which were translated to English, that's a pretty good ratio, I think. Yeah. And also, this is, I think it's the first time we actually released a video with 3 audio tracks. So that's originally German, translated to English, and also translated to Schweizerdeutsch. That was the yesterday's Hacker Jeopardy, if I'm not mistaken, so if you want to watch that. All right, so if you want to know more details about how the post-processing works and so on, you can go to our wiki. The setup described there is not exactly what we do on Congress, but many of the parts are still the same. So there's some documentation there, and there's also a talk from Frostcon linked, which explains some of that. So see you at Easter Hack, and have a nice day.
All right. So we're going to start switching speakers already and might do 1 or 2 very quick questions because we are running low on time. So if you have a question, I mean, Signal Angel, go ahead. You already have a mic.
The first question from the internet is, still buffering, what were the audio problems during the opening event?
He would be able to explain more about that, but the audio problems during opening. Can you?
Black magic.
Yeah, some magic happened and it didn't do the magic anymore. So, yeah. Any other questions? Yeah.
Did you think about broadcasting the streams on DVB-T or DVB-T2?
Yeah, we thought about that. Like we tried that last Congress in preparation for camp, and we ended up deciding not to do that this year inside the building because it's not really all that useful, and because propagation of radio inside a building is not all that good, and the idea during 31C3 was to evaluate the technical problems, and we managed that, so we didn't do that. We were thinking about doing broadcast, like putting an antenna on top of the building and broadcasting to Hamburg, but that didn't happen because of radio license issues, but we might try that next year.
Okay, all right. I think we're running out of time, and to give the other teams chances to speak, we're gonna move to the GSM review.
Right. Hello, hello, hello. Yes. Okay. Good. Thanks. So GSM, we had a test network again this year, but there's a GSM spectrum situation in Germany at the moment. So the regulatory body, the Bundesnetzagentur, they in 2015 auctioned away the test spectrum, the DECT guard band that is between the frequencies used for GSM and the frequencies used for DECT handsets. So because this spectrum is in between the 2 ranges, it's traditionally been held free because, you know, there might be they might sort of bleed into each other. Anyway, now it's gone, it's auctioned off, and so we couldn't apply for a test license. Well, we could apply, but we wouldn't get one, and it looked really bad. It looked like we would get no spectrum at all. And so Harald Welte, one of the Osmocom developers, he wrote a blog post about this, and a few days later, saying in his blog post that it seemed like we would be able to have no network, actually, because of this situation. And a few days later, he was able to write another very good blog post saying that we would have a network, because he got some contacts from, somebody from Vodafone got in touch and said, well, actually, this isn't being used just yet, so it's all right for you to use it one more time. They gave us permission, and we applied at the Bundesnetzagentur, and we were assigned one more test license. So that was great. We had 7, well, some of them are still up. We had 7 BTSs operating in the building. That's a little bit less than we've had previous years. They were each on their own ARFCON, their own frequency in the 1800 megahertz band, one in the rooms, 1, 2, and G, the larger room upstairs, one in the GSM room upstairs, one outside here in the foyer, and one 2 stories up, and one over in the hack center. So we did some new things this year. We implemented Hofrate, the Hofrate audio codec, which means that we were able to accommodate twice as many calls as previously. That's good. Now there's also an open source, working open source implementation of this, which was indeed finished during Congress now. And we also operated GPRS for the whole event on one time slot on each BTS. So that's 1/8 of the frequency capacity was reserved for packet data, and this was used, and it worked. The thing is, so if you do this, you have to determine in advance how much frequency spectrum you're going to allocate to packet data versus phone calls. And that's sort of fixed. It's not so easy to do that dynamically. So we started small, and let's see what happens. So we had some subscribers. I'll show a graph in a bit. Lots of SIM cards and no stupid bots this year. That's good. Peak activity, 66 calls within a minute was the maximum load on the network. And 38 SMS messages sent within 1 minute. The total number of SMS messages, 15,939. So well done. And it seems that about 450 or so of them didn't actually didn't arrive at their destination. Maybe the phone was switched off for too long, or there was no subscriber with that particular number, who knows. There was some GPRS traffic as well, no gigabytes, right? But megabytes, at least something. Let's start small. 116 or so megabytes received by the network, so sent by devices, and 475 megabytes transmitted by the network, so received by the devices. And some pretty graphs. This is a snapshot from a little while ago. The 3 on top I already went through. That's the number of active subscribers and the total number of sent messages in GPRS traffic. And on the bottom you see the channel load, so the activity of each BTS, each of the 7 BTSs that we were using. Finally, so what about next year? We don't really know. It doesn't look that great, and it's pretty certain that Vodafone is going to be using their spectrum that they've acquired next year. And sad panda, sad face. If you have any way to help us out with some spectrum in downtown Hamburg between Christmas and New Year's in 2016, then we would love to talk to you. And this is really a unique and important opportunity to exercise the open source software and hardware that we have for cell phone technology. I know maybe you caught Harold's talk on the new 3G work that is slowly coming off the ground, and by next year, I would be super excited to see that implemented. Now, I mentioned, so if you can help, please get in touch. I mentioned SIM cards. As it turns out, we found half a box of SIM cards left over, so if you're interested in those, come find me after the talk. That's it for me. I guess we can take some questions.
Yeah, so we're gonna start switching speakers already, and in the meantime, take a few questions. So if you have a question in the room, run to one of the microphones. If the Signal Angel has one, he waves his hand like he does right now.
A question is, were there any special services provided via GPRS, and were there Congress WAP pages? Still remember that?
There were no special services implemented by us, and there was no WAP content provided. But if you're interested in doing so, please get in touch, and we'll make sure to set something up. Oh, there's one more thing I should mention about the SIM cards. So the SIM cards from 31C3 a year ago, the ones from camp this summer and the ones from this event, they are all Java cards. And if you're interested in acquiring the keys on these cards, get in touch with us. We can give them to you if you want to implement, for example, some SIM toolkit applets. And there's some source code that was released just before Congress as well, if you're interested to work on that.
Okay, perfect. Maybe one final very quick question.
Have you tried to combine the text messages from the voice over IP with the SMS? Because that didn't work, I think, but it could be interesting.
Have we tried to combine text messages over packet, you mean?
Yeah, there is a voice over IP also to call, and but you can also send text messages with that protocol, but
do you mean
it was
SIP?
not possible to send SMS. SIP,
do you
yes.
mean SIP text messages?
Yes.
Okay. No, we haven't tried that. There is no SIP to SIP to SMS gateway. That's also an interesting project if anyone wants to work on that. Should be pretty easy. The POC infrastructure is easy to integrate with.
Okay, thank you.
Okay, perfect. You are the last question. One sentence question, one sentence answer.
My question is, what kind of hardware was involved in this entire network? I'm mostly interested in the BTS.
The hardware we used are Sysmo BTSs, and what was the second part of your question?
That I was mostly interested in the BTS.
All right, yeah, so the BTS is a Sysmo BTS, and it has an Ethernet connection to a server where we're running the OpenBSC open source software to control all these 7 BTSs.
Thank you.
Okay, perfect.
Thanks.
Thank you. And we technically have 2 minutes left for Silk Road, but we might run 1 or 2 longer. So yeah, please, Silk Road.
Yeah, hi. We are part of the team that set up this year's Pneumatic Tube network, but we also attended camp. Some people thought we weren't there, but we actually were. Our village got located or moved to another spot, so we weren't able to build the network we wanted. Part of the reason was because there were security ways that we couldn't cross, but we didn't. We tried to cross them. Turns out that the clay soil in Mildenberg is actually pretty hard to dig trenches into. We also have some statistics from camp that we couldn't show at the last infrastructure review. So all in all, there are about 118 capsules sent from our central node. Unfortunately, as most of you know, there was a little downpour at the camp one of the last days. So our measuring hardware that we would have loved to use at 32C3 somewhat corroded there, and we weren't able to use it. So this year's network looks like this. It's a bit larger than at last year's Congress, but this year we were also able to handle all the traffic from a single central node. So most of you have seen the router upstairs. So it's able to route all the traffic to the central node and back to all the nodes again. So some new developments we did. For the camp, we actually wanted to collect the statistics from all the nodes. And since we planned a large network with nodes that are far apart, we figured we needed some kind of two-wire bus that has to use cheap cable. So this is somewhat RS485-ish two-wire bus. You can check out the code on GitHub and the hardware schematics. And this is also the stuff we use to control the routers. Yeah.
Yeah, because of that that central approach, we needed some communications. That's why some other guys set up some field phones to every station. And they were heavily used, even especially in the mornings when the smaller hackers were there. That was quite fun. And that's our router. It was really fun. It had 3 tubes, 1 tube coming. One tube coming from the hack center and 3 other tubes. One going to the POC, to Garderobenfoyer 2, and the other one was actually, yeah, we'll come to that later, it was really fun. Because of that central approach, we could provide suction as a service, so that, yeah, got rid of that noise problem. We had some, no one really who could provide an electrical switch, so we choose another approach. Yeah, and we had that 3rd tube at the router. That was really, really fun. It was good for trolling podcasts. Because it was on the stage at the Sendezentrum. Yeah. That was almost everything. We would love to have more people who help us. If you want to help us get everything set up, come here on day -3 or so and just help. If you have nice ideas, contact us via the mailing list, and yeah.